Hello everyone, thank you for watching my talk. My name's Stuart and I'm here to explain how JSON Schema can be the integrator's secret weapon. Now this talk is in the format of a war story, and that means I'm not going to be going into what a JSON Schema looks like, how to write one, how to use a validator, anything like that at all. After this talk, if this talk has interested you in learning more about how to use JSON Schema and inspired you to get started with it, check out my slides. This QR code will take you to an existing talk of mine online that will help get you started. So, what was the integration we did? Last year, I joined a company that had just been bought, and I was asked to help them with the integration that they'd planned with their parent company. Now, what the parent company wanted to do was to retake both companies, take themselves and the company that I just joined, rebrand both of those, and then launch them into the market as a new unified brand. This was going to be a project with marketing activities in the run-up to launch day, and a launch day that couldn't move. It was going to be high profile, so it had to work. There wasn't time to integrate our products deeply. It wasn't going to be possible. They were two companies with very different philosophies, very different tech stacks. So what we decided to do was to integrate the overall experience between the two companies. So it didn't matter which product stack you logged onto, you could move easily. A user could easily move across to the other product, and it would seem seamless that way. So if you imagine this as a high-level architecture diagram, looking at responsibilities for the parent company and responsibilities for the company I joined, the company that got bought. We were going to call some RESTful API endpoints to tell the parent company what our users were doing and help hand users off to the parent company. And they would do the same. If a user came in through the parent company, they would be handed off to us using some API endpoints, some synchronous RESTful API endpoints. And we were also tasked to provide some asynchronous webhook endpoints. The parent company was going to use this integration as an opportunity to take control of user registration and also of things like product subscription management. So they'd need these webhook API endpoints to tell us what had happened when users had signed up, and also when users were buying products, updating their subscriptions, that kind of thing. None of these endpoints existed. We had to build them all from scratch. And this was a project that ran over the Christmas period as well. So we didn't have a lot of time. It was a big challenge. Now, there's a lot went into this integration, but JSON Schema was something I brought in as part of this integration approach. And I'm here to explain why it made a big difference despite the small role it played. Because at its heart, this integration was all about building great APIs. JSON Schema is a great tool for that. Before I explain how JSON Schema helped us, let's gain a common understanding of how JSON Schema fits in to your overall tech stack. So imagine this as a high-level lifecycle diagram showing the lifecycle of an API request from the point of view of the backend server. The backend server receives an API request, which will have a payload of some kind normally. It will do some work, and it will produce an API response. It will publish that response and send it back to the caller. Now, somewhere in the middle of there, you've got your business logic. You're responding to a query, you're performing an action. That's not enough for your life cycle. We've learned the hard way over decades now of having services on the internet that these API endpoints have to be hardened. You have to treat incoming request data as untrusted input. It must be validated before it's safe to use. No choice in this whatsoever. So for ages now, what we've been teaching people is this concept of filtering your input and escaping your output. Now, if you're building APIs that work with JSON data, you can use JSON Schema to help make this even more secure. If we go back to our lifecycle diagram, we can introduce JSON Schema as the very first thing we do in that life cycle. We can use JSON Schema to look at the request body that's come in and validate its format. It can say, right, I'm expecting an object, so have I got the right object here? Does it have the right fields? Each of these fields, does it have the right data type? For example, if I'm expecting a field that's going to have an email in it, do the contents of the field have a well-formatted email address? If I'm expecting a date, is the field a properly formatted date? If I'm expecting an array, does the array have the types of data I'm expecting inside it? Does it have the right number of minimum values? You can put min and max on arrays, on numbers and things like that as well. So you can actually, in a very deep way, a very strict way, specify the data that comes into your code. And if the JSON Schema validator goes, nope, that's not happening, you've sent me the wrong data, you can shortcut the rest of the life cycle and send back a HTTP 422 response to say the validation has failed. And in this way, you can protect your business logic from data that's not safe for it to handle. And as a result of that, there's another little benefit for those of you who are programmers. Your controllers then thin out a little bit more, and they go back to just being responsible for loading and executing your business logic. So that's how JSON Schema fits into the overall stack, and that's how it works. So now we've got that common understanding, let's look at how JSON Schema helped us deliver this integration. Here's the headline. On our launch day, we went live with no outages whatsoever. We had no major issues either. Any minor issues that turned up, we were able to fix those through our business as usual process over the following weeks. We didn't have any sort of crisis whatsoever. We had a great launch day. So how did JSON Schema help us with that? Because there's a hell of a lot more goes into successful integration than just data validation. Well, JSON Schema was a key part of a philosophy I brought into the project, which was to fail early and fail hard. And this is one of the key takeaways I want you to take from this talk. If you think about an integration and you're integrating two companies together, it's ultimately about your user journeys. Come launch day, if your user comes along and they can't do the thing they used to be able to do because it no longer exists, you're going to have a bad launch day. And if that user journey does exist, but is broken because your implementation has gone wrong, you're also going to have a bad launch day. And that's why I'm a firm believer that to get your integrations right, you need to get the right requirements, i.e. you've got to find these user journeys and make sure you know what they are. And then you've got to implement them well. These user journeys have to work without a hitch. And failing early, failing hard is part of achieving that. You see, from my point of view, the earlier you find problems, you find faults with your integration, the longer you've got to fix them. That's very important on a project where you've got an immovable deadline. You need to front load finding and fixing your problems. So if we go back to the life cycle, JSON Schema is providing us that feedback loop. If our integration API is called with the wrong data, we immediately return a validation failed response so that the caller knows that their integration is broken and they need to fix it. So what kind of things did we catch with JSON Schema? If you're building an integration, you're going to be iterating. You're not going to get it right very first time. So by having this feedback cycle in place, we were able to help people as they were iterating, show them where their integration was wrong and what they needed to do to fix it or complete it. Something else we caught, which I must be honest, surprised me, which is why I've mentioned it in here. You've got two independent companies with independent project teams working on this integration. And we found that sometimes an integration would change after it had been done, signed off, and considered complete, and we'd moved on to other things on the project. Because we were using a shared JSON schema for all of the API endpoints, we were able to catch problems where an integration got changed after it was supposed to be done. It helped us catch surprises like that. It was very handy. And that was something I wasn't expecting, which is why I'm mentioning it here. Now, you may be sat there thinking, I've already got a validation code in my application. I've put a lot of effort into handcrafting this validation code. Why do I need JSON schema? Isn't my existing validation code enough? And in all honesty, in my experience, no, it's not. Handcrafted validation code, in my experience, often has a number of failings with it. The most common one is that it's either incomplete or it's completely missing. If you go through your application, I bet you can find at least one API route where at least some of the fields aren't validated at all. Where it is there, you may find that the validation isn't strict enough. For example, you may find you're just checking for a string instead of checking for an email address or a well-formatted date. You may be checking that something's an array, but you may not be checking the contents of the array are accurate, especially if you've got an array of nested objects, that kind of thing. Another one that handcrafted validation code regularly misses is making sure there are no extra pieces of data passed across. When you're doing an integration, it's quite common to pass fields in with the wrong names. And if you're not checking for extra fields and rejecting those, then that can help mask problems. In my experience as well, this handcrafted validation code tends to be created at the point of use. It's often not as reusable or reused as one would like. And so it's not unusual to find two API endpoints that take the same kind of data, but they validate that data in different ways because of this handcrafted nature. And then finally, another problem is it's code. It's handcrafted code. If you're working in multiple tech stacks, you have to reproduce this validation in each of those tech stacks. And then you're coming into the problems of inconsistency due to implementing it more than once. So these are all regular problems found with handcrafted validation code. Now, our JSON schema was able to catch more than just these problems. We were adding JSON schema to an existing system that already had handcrafted validation code, which meant our database contained data that had already gotten through this handcrafted validation code. And because of our integration, we weren't just sending user input across the integration to the other company. We were sometimes matching, also pulling out data from our database and sending that across. And the parent company was doing that with us as well. And this helped us catch some data fields. Email address was one, customer IDs was another, for example, where the data in the database was a surprise. It wasn't matched the specs we'd agreed. And that helped us find and fix this handcrafted validation code in the production systems as well for other endpoints that were nothing to do with the integration. Now, not everybody is happy when you find these kinds of faults. Unfortunately, not everyone looks at this as the positive that it is. Instead of looking at this and going, hey, we've just made our application more secure or more correct, if you prefer. Some people get upset with this, and we had a problem with this on our project. We had a very senior manager who was very unhappy with this. And on several occasions, what he wanted us to do was to take away that JSON schema layer. He wanted to go back to just using the handcrafted validation code. We had several requests for that. My advice on this is unequivocal. Be polite, but be firm. Say no. Never switch off validation that's accurate. Never do it. At best, switching off validation is an unethical thing to do. That validation there is to protect your customers and the data that's in your database from being stolen. It's part of that. If you work under GDPR, if you work under security assessments like ISO 27001, 2013, things like that, At best, and I'm picking my language carefully here, at best, switching off data validation is problematic at best. So don't do it. Doesn't matter how senior a job title that person is, they're asking you to do something that they should not be asking you to do. Say no. See, I've got some sympathy with the idea that business logic, the business code should be doing validation. But we're back to it being handcrafted validation, which means it's got all the problems that we discussed earlier. It's inconsistent, or sometimes even missing. It's often not strict enough, and it's often inconsistent. So you want JSON Schema to help protect you from the nature of this validation code. Now, I'm not saying you should just use JSON Schema. If you're trying to build robust systems, you want both. You want JSON Schema for input validation, and your business logic should be performing defensive programming as well. You should be doing both. Now, why do you need both? You can't delegate your business logic into JSON Schema. You can't do it. JSON Schema can tell you if a field is an email address, for example, but it can't tell you if it's the right email address for whatever operation is being performed. Can't do that. That's the role of your business logic. Equally, your business logic, it runs a lot better if it's getting data structures it can trust. We are well into the era of happy path programming now. We're what, best part of a decade into that era now, something like that. A lot of code today is written on the assumption it will always work. And especially in scripting languages, how many times have you seen your applications crash because your application tried to access a field that didn't exist in the data that had been passed in, or was the wrong data type and the type conversion caused problems, things like that. If you validate the structure of your data before it's passed into your business logic is going to work a lot better. And this means my advice is you should have both, and your life cycle should look like this. You should be having JSON Schema up front to reject any data that's badly formatted. And then your business logic should be doing context-aware checks to see, right, okay, I've got an email address. It's not an acceptable one. I'm also going to reject this operation. I'm not going to make sure it goes through. So both of these layers should be rejecting data based on validation. And that's how JSON Schema can help you in your integrations. Let's go on and talk about the elephant in the room. Let's talk about the role of OpenAPI Spec. If we go back to my high-level architecture diagram, this looks tailor-made for OpenAPI Spec. The natural instinct of people who are familiar with it would go, let's use OpenAPI Spec for all of this. So why am I talking about JSON Schema and using JSON Schema for validation? Why am I not talking about doing this with OpenAPI Spec? It was a matter of timing for us. When we did this, the latest version of OpenAPI Spec was version 3.0, not 3.1 like it is today. 3.1 wasn't out yet. I'm a firm believer that your JSON Schema validators are mature, robust, correct, they're trustable. They will get the job done. OpenAPI Spec 3.0, unfortunately, in my opinion, the way it describes schema is a dead end. It uses a dead schema dialect. And the tooling around that in the stacks I work with, I can't trust as much. Now, I mentioned OpenAPI Spec 3.1. It's now out, and it now supports bang up to date JSON Schema, which is fantastic news. So eventually, we will be able to do this in a year or two's time and say we did all this using OpenAPI Spec, but we're still waiting for the tooling to catch up. We're waiting for the latest JSON Schema drafts to be supported in a mature manner, things like that. But eventually, we'll be able to talk about JSON Schema and say that it came out of our OpenAPI specs. We just lifted it and reused it, which will be fantastic. It doesn't mean we didn't use OpenAPI Spec. We definitely did use it. What we did was we used it to document the APIs during our negotiations between the two companies. Another key takeaway I want to urge you to use from this talk. Write your specs first. Use that to drive your code. Don't do it the other way around. And what I'm talking about here is a situation where you're building an API in conjunction with a third party. The two of you are collaborating and negotiating on this, which is what we were doing for an integration. We had, as I said before, two different companies, two different tech stacks. So an OpenAPI spec was the one thing both companies could contribute to. And that helped the negotiations really well. It helped us really get the detail bottomed out and helped us communicate effectively with the developers who were building these APIs. It created, if you like, a sense of equality, a level playing field between the two companies for the negotiations. It was a big help. And then what we did was we took those OpenAPI specs and we made equivalent JSON schemas that we use for runtime validation. And remember, that headline again, this helped us launch with no outages, no major problems on the day. We had a great launch day. Now, just because the integration's over doesn't mean the story's over. JSON Schema proved so useful that we decided to start using JSON Schema even more post-integration. If you look again at our lifecycle of a HTTP request for an API, our API endpoint, they publish JSON documents. And if we're publishing a JSON document, we can validate that document using JSON Schema before we send it back to the caller. So we can introduce JSON Schema as a bookend. We can take our response payload, we can validate it on the server before we send it to catch any obvious bugs in what we're sending back as a second way to guarantee that we are meeting the promise we have made to our customers, that we are delivering on our API spec. Very helpful. And we can go further still, and we were doing that as well. If you think about a single page app, which is what we use for our front end, its typical life cycle is something like this. You get user input, and eventually that triggers a HTTP request to the back end to do something in a headless format. And the back end returns a response. It returns the API response. That response goes into a Redux style store, and then your reactive components respond to the fact the data's changed. That's roughly the life cycle of a single page app in today's tech approach. So if we're getting a JSON back from a backend server, what we can do is we can introduce JSON Schema into our single page app, and it can validate the JSON response that's been received before the data goes into the Redux store. Which means that if anything goes wrong and we get unexpected data back from the server, we can protect our users by never updating the Redux store with the bad data. And that's a really big help. Now, I've moved on, and I'm currently helping a company who got an event-driven architecture, passing messages around from microservice to microservice using Kafka and Kafka's event streams. And I'm currently helping them put JSON Schema in place to make sure that events that are published to Kafka are always compliant with the shared spec. And how is that going? That is a story for another time. Thank you for watching. Now it's time for our Q&A. Hello, hopefully you can see me and hear me. So, questions and answers. First of all, thank you everyone for the conversation in chat as we were doing that talk. That was awesome. Thank you. So, questions, what have we got? We've got a question from an anonymous person. Are you satisfied that your schema-based validation results in understandable error messages? And do you see problems where a message relates more to the design of the schema than the logical problem? I think that's a very good question. And I think there is a problem here with JSON Schema for sure, or shortfall, if you like. The error messages that come back are dependent upon whichever validation library you're using. There's no standard that I'm aware of, and Ben will be able to answer in the chat if he knows better than me, There's no standard that I'm aware of for designing the human readable messages that come back at all. It's each library's up to got its own approach, and it's free to do whatever it wants. Now, what I find I do with those is I take the schema and the rejected request body, and I pop them both into a validator tool, validator.net. And then often when you've got a validation error, what you can do is you can just cut out bits of your schema to narrow down what's causing it, especially if you've got a large schema that uses many one-off or any-off types there. And you can very quickly get down to what the root cause is. But you do need the full request body to help you track that down. I hope that answers your question there. And we got another question as well. What are my thoughts on async API? I'm afraid I've no experience with async API at all. I can't answer that one. I believe there's a session on async API tomorrow. I added it to my agenda for the talk. I'm going to be going along and learning about async API there. And then Mikhail has asked, do you use any automatic linters for JSON schemas? I don't at the minute. If there are any out there, I'd love to learn about them and love to have a play with them as well. But at the minute, no, I don't use any automated linters for JSON schema. I'm going to turn that question back. Is anyone else using any automated linters? And if you are, what problems have you found that those linters solve for you? I'm just checking on chat before I answer Ben's question. So Ben's confirmed that what I said is correct, that there's a standard machine readable output, which the libraries can build upon to provide interoperable human readable error messages. And Stuart McGregor's replied that he doesn't know of any useful linters for JSON schema at the moment. Okay, now back to Ben's question. So Ben's asking, how do I write my JSON schema? The honest truth is carefully. What I tend to do is I tend to build from small data types upwards. So for example, if I'm building a large data structure, let's say a task in an event-driven system, you've got a task model that you pass around from microservice to microservice, for example, then I'll start at the high level first of all and sketch out the task and the fields. And then for those fields, what I'll do is identify individual data types to cover those fields, and I'll extract those out and put those into the schema as separate data types. I'm a great believer that a good schema is as strict as you can possibly make it, but no stricter. And I find that getting into that strictness and then coming back from there to revisit your larger data types and see where you can reuse. For example, ID fields are a great one. Create an ID type and then drop that into all of your fields and reuse it. Try and reuse as many of the field definitions as possible with your JSON schema. That's what I would say. Oh, Ben said he actually meant more the tools. I actually write schemas entirely by hand, Ben. I don't use any tools for that. Mikhail said he uses Spectral. That's the linter from the folks at Stoplight, isn't it, Spectral? And Ben's saying yes to that. And Terry's saying that he hasn't seen any tools as well. And Mikhail's explained why he uses a linter, which is awesome. It allows him to catch typos. That's a good one. Inconsistent usage of some parameters, missing descriptions, etc. So then Mikhail's going further than I do and is making sure that his schemas, by the sounds of things, are very rich in information, which I think is fantastic as well. So that sounds like a very good area where a linter can catch some problems. I'm just scrolling back through the chat. Thank you for the kind words on the talk. I'm not sure I agree with the great narration. I'm rubbish at doing pieces to camera. I need more practice at it. So Shane's asked, what validation library do we use for client side? I'm happy with AJV. I would say I wish the docs for AJV matched the code a little bit better. I think it gets out of sync there. But AJV is pretty fast and is certainly fast enough for the kind of clients that I work with. Over here in the UK, unless you're building for a bank or you're building for a supermarket, we don't really have large systems, not like you get in America, for example. I've been on what for us is a large government project, and it still wasn't that busy in terms of concurrency requirements. So things like AJV are certainly okay for us. And I found AJV's support has been the least buggy, the most reliable over the years as well, which I think is very important. If you're putting all your faith into something like JSON Schema, Ben's just chimed in to say it's the most well tested as well, which is good to know. But yeah, if you're putting so much faith in the JSON Schema, I think choosing a validator with a good pedigree is a really good move. So Shane's pointed out that AJV has a YAML parser as a dep. I mean, if you look in your node modules folder, it's so large anyway. I'm not too worried about that with AJV, and hopefully if you're using something like tree shaking, you can slim that down as well. I don't know. I've never looked into that. If you're bundling all this stuff into like a Docker image to deploy, for example, I don't find AJV adds that much to the overall overhead of the overall container. Stuart McGregor's pointed out that Newtonsoft does the job fast enough for us. I'm not familiar with that JSON Schema validator, Stuart. Can you tell everybody? It's .NET. Fair enough. That's why I'm not familiar with it. .NET's not my world. I must leave that to people who are also far more experienced than me. So we've come to the end of the session. I'm happy to hang around and ask questions. I don't know if anyone needs to leave for anything else. I'll happy hang around and ask questions. And I believe there's a networking session later on as well. I'll hang around for that as well if people want to approach me for more questions. But just to finish, Eric said, any tips for you in JVM land? I'm sorry, I haven't worked in JVM land for a very long time, so I can't offer you any good advice with that. What I would say is Ben's part of the JSON Schema folks. They run an excellent Slack community where that's a great place to go and ask for things like that, to get advice from people who know more about it than someone like me. And Ben's kindly posted a link to it there as well. jason-schema.org/Slack. It's a great community, very friendly. I can't recommend it enough if you need help with JSON Schema and also languages. And hopefully, if we could do with Stuart on there, because he's recommending both .NET and Python libraries. So it sounds like Stuart is someone people can pick his brain if they need information in those kind of worlds. Any more questions before we leave and go over to the networking activity? Going once, going twice. All right. Thank you all, everyone. You've been a great audience. Really loved how the chat was going while the recorded talk was going. Anyone wants to catch me in the AirMeet hosted networking activity, feel free. And if not, thank you for coming along. Bye, everybody.